Okay guys, page 133. Now this is a very good question. Now it's the kind of thing you could say coming up in the short questions, no bother, where you're given a line and a point and get the shortest distance from P to AB. Now the easy way to do these and the best way to do these is make a triangle out of it. Because if I just use the set square there for a second, if you make a triangle out of it, just try and fit this in, set square, I'll just zoom back for a second. Okay, so if I said here's a triangle, what's the shortest distance from this point to the opposite side? Well, it's just perpendicular to the side here. So like a 90-degree angle, that there, perpendicular to this side, that is the shortest distance to get from that corner of the triangle over to the line opposite. And it's that idea, it's that principle, but there's a few little bits and pieces that need to be taken into consideration. So step one, make a triangle. So there's the triangle P and AB in elevation. Here is it in plan. There we go. Now I want to get an edge view and a true shape. Okay, so an edge view is when it appears as a line like that, like the set square we're seeing as a line, and then the true shape is when you're looking at 90 degrees and you're seeing the full thing, because that's the only place you can get the perpendicular line on a true shape. So I'll just stick this in red there to help you. If you put any horizontal line, but generally I'll take it from P there because it makes life easy in plan. You already have one point. If you go through a point here, then you already have P in plan, so it just saves a bit of work. So when I bring there, call that X. When I bring X down, it's on AB. So here's my horizontal line in plan. So if you walked along that line, you'd be going horizontal. It would be downhill to B, uphill to A, but if you go from X to P, that would be horizontal. And if we look along that horizontal line, we are going to get ourselves a point view of the line and an edge view of the plane. So I'm just going to look along it. That's the angle. Set up an XY line. Project them out there. So B is just a little bit. A is up pretty high. Here's P. Yeah. So we are projecting from here, last XY line, back. So B and A. So that here is the edge view of the plane. And that's the point view of XP. Just in case you doubt, if I just set that height there. So you can see there, so that is the edge view of the plane. And I'm going to take one more auxiliary view here now. So I probably have room to look up or down, it doesn't make a difference. Doesn't make a difference. I think I'll just look up the ways. So I want to look at 90 degrees to that plane. So that's my angle. So I'm going to keep the XY line pretty close here. So I'm projecting from here, last XY line back. So that's my first auxiliary. This is my second auxiliary. So I'm projecting from here, last XY line back. So that's my distance for A. Okay, just got away with that. Not that it would matter if it went on the other one anyway, but still. That's my distance for B. And finally, this is my distance for P. So B and A. And here's P. So that there now is the true shape. Now that's what I was looking for now. What I was saying there earlier on when I had the set square down there is that once you have the true shape, then you can apply the perpendicular. So you want to go from that point perpendicular to the line opposite. So that's what I want to do here. So I'll use a different color there now. I'll just use purple. So the shortest distance from P and this here is the solution. That is the shortest distance from P to AB. So I now need to transmit this information back the ways. So that's just a matter of keep projecting back at the same angles that we used to get there. So that's the point on AB here. And that is projected up to here. And finally up to the elevation. And I'm just going to draw that line in the elevation. And in the plane. And on the edge view of the plane you can't see that line, because when you're seeing on the edge view, so that line would be going from there to here, but you can't see it on the edge view. So shortest distance from P to AB, make a triangle out of it, edge view, true shape, get your shortest distance, and the key thing there is that that has to be perpendicular. The shortest way is to go straight or perpendicular towards it. Now this question here, okay, so it says given the projections of a lamina, which is just a triangle or a flat triangle, 2D triangle, draw an edge view of the lamina and get a true shape. Now this is the absolute bread and butter of all these questions. And we do this so often. We just take a horizontal line and elevation anywhere, but it's just a little bit faster to take it through a corner that you already know. So I only need to find X now in the top view rather than having to, if I took it up here it would work fine as well, but just spare a bit of time. So there's a horizontal line in the front view. Here's X on AB. So XC is a horizontal line. That is a horizontal line looking down from above. So if you walked along X to C, you'd be going horizontal. If you went to A, you'd be going uphill. If you went to B, you'd be going downhill. So there is our horizontal line. We want to look along that horizontal line and that's going to give us an edge view of the plane. So that's the angle to look at. Put an X-file out here anywhere. So we're projecting from the plane, so it's the last XY line back. That's where our distances come from. So B is the shortest. Then C, then A. So that should give us an edge view of the plane. All these points should line up, giving us so that's A, that's B, and this is C. Okay, so we now have an edge view of the plane, and if I look now 90 degrees perpendicular to that, I will now see the true shape of it. So there's my XY line parallel. I want to look at 90 degrees to that. So again, always the rule projection, projecting from here, last XY line back. Okay, so B is the furthest. There's A. That's C. Now, because this is the true shape, this view should be bigger than ABC in elevation or in plan, which it is. Like the true shape is the view where it appears the biggest. So like this true shape should be bigger than any of the other views. So there's our true shape. I'll just put a TS for true shape. So there's A, B, and C. So draw the edge view and the true shape. There we go. That's it. And then here we've got something, again, something a bit similar here. You've got a triangle ABC and a point P, and they're saying find the shortest distance from P to ABC. So again, we're going to need an edge view of ABC. You know, this question could be given in lots of ways. You could say, you know, there's the triangle, sloping surface, and a helicopter needs to land. What's the shortest distance you would have to go to it, or you know, whatever. But you know, a question like that would be put in some kind of context. But first thing we want is an edge view of ABC. So I'll keep this in red just to make it easier. So a horizontal line from C. It doesn't matter. Look, I'm going to do it without using C there, which is just a small bit slower. So I'm going to call it X, call it W, Y. Okay, so W is on BA, Y is on BC, so that there is a horizontal line. That is the angle that I want to look at. So I'm going to look at that angle. So if I look at this angle, it's going to give me an edge view of the plane. So just put an XY line there. Okay. Now we're projecting from here, last XY line back. So B is the closest to the ground. C is next. Forgot C. Okay, so C is next, just double check that's still right. And finally A. Now 2 points would have done really, because I could have just taken A. And if A was correct and B was correct, well, that would have automatically given me C. The benefit of taking all of them is, you know, it just kind of proves that you're right. It reassures, I suppose, is the word. Now, just to prove there, if I took the height of my red line here, which is W and Y, and step that up there. So that's the point view of that red line. So that there is the edge view of ABC. But now we want to bring P. We want to bring P along as well. So just project that now. So P is, just drop the perpendicular here to be accurate, taking the height. So projecting from here, last XY line back, oh yeah, so projecting from this view, last XY line back, that is my height for P. So I'll use purple again here. So if I wanted to, the shortest distance would be perpendicular to that plane. So that there is my shortest distance. So when I project that back, okay, so somewhere between here and there, somewhere on this line, I'll just put that line in a little bit heavier, somewhere on that line is my solution. Now there's, I suppose, two ways I could do this, and what I'm going to do there next is I'm going to bring that up to, I'll put a color on this so that you can see it a little bit better. So somewhere on this golden line is the solution. I'm going to bring that line up to plane, or up to elevation, so it's going between there and here. So somewhere on this line is the solution. Now, what I could do there is, seeing as we were taking distances from there, I could take that distance and step it up here, but you can see it's almost parallel there, it's very close. So how do you know exactly? Well, I do know that it would be perpendicular to that line, so I could put this set square down along here and go perpendicular to that line. That is one way of doing it. So that there would be my solution there. That pink line, that is the shortest distance, but I'm a bit caught for space here now, but like another easy way, or a very nice way of doing this, but I am caught for space, is if I took one more auxiliary view here, which I think I will just do, is if I took one more auxiliary view here. So that's my angle to look at, and if I projected them out, now I'm going to actually use AB there as the XY line as well, just to try and keep this on the sheet. Okay, so if I took one more auxiliary view down here and projecting from here, last XY line back, so C would be here, B and A. So A to C, this is going to give me the true shape of that plane ABC. And P was this distance. Okay. So in the true shape view, that's where P is, which is here's that second dot there. So that there is the point. So I'm now seeing P in line with the true shape of this, so it's just either straight below it or straight above it, depending on which side. In this case, P is actually on the far side as I look at it, so I'm kind of projecting back up towards myself. Now, how would you bring that information from there back to here? Well, I suppose there's a couple of ways, but I could just take that distance and that distance there would have been taken from here. So I could have stepped that up, but one of the easier ways is, probably an easier way is, if I just draw a line from B through the closest point, that green line there, so it's here on CA. So it's here on CA. So that there is my green point. I'll project that back again. So that's on CA. Yeah, I knew there was something wrong there. Sorry, I knew there was something wrong there when I brought that back. That green, the end of that green line on CA is here. And when I project that over, then it's here. And when that's joining back to B, okay, so that's tiny bit off there now. Tiny bit of inaccuracy there, but the method is right. The method is right. So that's two ways of doing that. So I hope you enjoy. See you later.